welcome to the first MAT 228 video. So to start with, I'd like you to take a look at this least squares applet that demonstrates what the least squares in least squares regression actually is doing. So I've given you the link to the applet, and so when you open it, I would like you to click here, then click on the arrow, and this brings up the sum of the squared residuals. The blue line is the least squares line. The green dots are the data points. Okay, and so this distance right here is the residual, okay, and then this box here represents the squared residual. You can then use these red points right there to move the line around, and as you do so, you can watch this sum of squared residuals, and you'll notice that it's the smallest when that line matches up with the least squares regression line. So that's the least squares part of it. It is the smallest sum of those boxes. So as I just said, you can move the red line with the red dots and watch the sum of squared residuals change. And notice that the quantity is the smallest when the red line matches up with the blue least squares regression line. You can also play around with moving the green data points around and watch the effect that that has on the blue regression line will change as you do that. So pause the video here and take a few minutes to pull this app up and play around with this. Then watch the first StatQuest video and pause it. So yeah, pause at approximately the 8-minute and 26-second spot, and then look at the next slide on my video. So he's in the video, he talks about like rotate the line, rotate the line, rotate the line, and then he has a plot like this where these points represent those different sums of squares, like up there. And what he's showing is that the minimum sums of squares comes from our blue regression line. So that's what he's talking about when he says rotate the line, rotate the line, rotate the line. Just the kind of thing that we've been doing in this app right here. So we have total variation equals the variation explained by the regression line plus the unexplained variation. The total variation is the variation around the horizontal line, which in his notation is that he uses variation around the mean. The variation, or the unexplained variation, is the variation that still remains around the regression line. And in his notation, that's the variation variation around the fitted line. Okay, so notice if we want to know how much variation is explained by the regression line, we can find that by subtraction. So the variation explained by regression equals the variation around the mean minus the variation around the regression line. Okay, so also notice like these are two components of the total variation. Okay, so each one of these is a percentage of the total variation. So R squared equals the explained variation divided by total variation. Or using the StatQuest notation, that is variation around the mean minus variation around the fitted line divided by the variation around the mean. So at this point you can go back to the StatQuest video and watch until around the watch till around the 11 minutes and 52 seconds. And then pause that video. StatQuest video. And return to this video where I'll explain some kind of notation that he has. So where we paused the video before, he used R squared equals variance of the mean minus variance of the fit divided by variance of the mean. And then all of a sudden in this spot he has sums of squares again. So let's kind of show how that make that leap there. Okay, so if we plug in for the variance of the mean, and we plug in the sums of squares mean divided by n, likewise for the variance of the fit, plug in sums of squares for fit divided by n, and if we do all that, what we'll see is that these n's cancel, and what we're left with is R squared equals sums of squares mean minus sums of squares fit divided by sums of squares fit, which is what he has in the video here at the 11 minute and 52 second mark. So at this point it seems that my pen has stopped working even though I've had it charging for a while, so it looks like this is a good point to end this video. So go ahead and finish the StatQuest video, and that's where we'll end for today, and we'll pick it up with actually doing some R work next time. Okay, so goodbye for tonight.